There you go. All right, welcome back from lunch. This evening, the module we'll be covering is the calculation, which is module 19. Be very basic. We will be doing area, we'll do volume, we'll do detention time, what else? Conversion of PSI to feet, yeah, and some pounds calculation. So we got a little of everything. We may not get to it all. We'll see how the flow goes. The way I like to do it, I don't like utilizing the PowerPoint for the math because there's a such thing as muscle memory. In other words, if I'm just clicking and you're just looking and just writing down, there's no muscle memory. But when we have to literally put it in the calculator, and that's the reason we provide calculators to you, you build up those muscle memory of how to do things. And math, like with anything else, can be very easy. It takes practice. The more you do it, the more you retain, the easier it becomes. And so that's the reason we go through the process of actually allowing you to put it in, work it out, follow the progression. Now, with any roadmap, I can get anywhere I desire to be, right? So in math, what's our roadmap? The formulas, okay? And like with any other industry, there are set formulas. Most of our formulas are based on the shape, and that's the first thing that I'll ask you, what shape, because that will determine whether or not I'm using one formula versus another. Then I'm going to look at the statement, or what's in the question. What are we given? And we'll plug those things in. Once we've plugged in what we've been given, and we apply the formula, the only thing left for us to do is what? Is to calculate. And it's going to be very important that we convert to whatever unit that they are requesting. So, as far as the math goes, our terminal objective, of course, is to be able to calculate problems related to basic water question. And we're going to look at squares, calculating the area of squares, rectangle, and circle. When you all do your examination, does the state require you to memorize your formulas, or do they give you? They give you the formulas? Give you a sheet. Great, great, great. The way we'll tackle the area, the volume, and all of those, I'm going to go through all the formulas at one time so you'll see how they relate to each other, and sometimes that helps you to remember the process, okay? So, when we're looking at area, volume, and gallons, how do you abbreviate average? AVG, very good. And what shapes do we normally deal with in our field? Our ground circle. Okay, we have cylinders, we have circles. Cylinders and circles will be pretty much the same. Any of you all have any rectangular? Yes, sedimentation basin. Excellent there. And so based on that, when we're looking at any plane object, our base formula would be the area, and that's what the A stands for in AVG, area. If I'm looking at any plane object, such as a square or rectangle, and the only difference in a square and the rectangle is that a square, all sides are equal, right? With a rectangle, we have two parallel sides that are equal. So I am looking at the legs of the right triangle to determine area. If I look at the sides of the right triangle, I have length and I have what? Width. So, area then is length times width. Okay. Now it's critical. In math, we cannot multiply at apples and oranges. You must have the same units. So, if they give me a unit in inch and they give me another in feet, that means I must do what? Convert. I have to convert either inches to feet or feet to inches, whereas I can multiply apples and apples. And let's say for the sake of this argument, we have feet times feet. So we have length times width. When you multiply units, you simply add them. So, feet times feet, there's an understood 1 here. And 1 plus 1 is what? So that will be feet squared, or you may say square feet. Same difference. So I can write it like this, feet squared, or I can write it like this, square feet. If I have feet times feet times feet, then I get feet cubed, super, or cubic feet. Excellent. Again, written either way. So, area, length times width, feet times feet will yield feet squared. My results will be in feet squared. So whenever they ask for area or what is the square footage, then I just simply plug in my numbers, length times width. All right. Volume takes into consideration the third dimension. If I have length and if I have width, what's my third dimension? Depth or height. Now, what's the difference in digging a trench down, building a ground storage unit up, or laying a round pipe long? Nothing. It's all directional. So, in some books, we may have length times width times depth. In other books, length times width times height. Or if I'm looking at a pipe, it'll be the pi r squared times the length of the pipe. Only directional, but notice one thing. In order to get from area to volume, we've added only one thing, and that will be height. And again, feet times feet times feet gives me cubic feet. Excellent. What do you think G stands for? Gallons. Excellent. How many gallons are in a cubic foot? You're ahead of the curve already. So the only thing that I've added for gallons in a rectangle or square is length times width times height or depth times 7.48. Excellent. And there's actually one other formula that we can follow suit with the same train of thought, and that will be detention time. What is detention time? By definition. Have a basin, huh?
Takes to make it goes through that basin.
Super. It's how long something is retained or moved through a basin. So in order to get detention time, I need to know the capacity of the basin, right? Well, gallons gives me the capacity in gallons of the basin. So that's already a given. So I have length times width times height times 7.48. Now that I have the capacity of the basin, what's missing? The flow rate. Very good. And so the only thing that I've added here is a flow rate. And I want that flow rate to be in gallons because this is in gallons. And I can convert it to gallons per minute, per day, whatever flow rate or whatever time variable that they're requesting. So now you've memorized 4 formulas just by starting with average. Average DT. Super. Can we do the same with the circle? Do I have a right angle with the circle? I don't. Most circles or most pipe are known or denoted by their diameter. Very good. So what is the diameter? If I were to draw a point in the middle of that and draw a line across, that will give me diameter, right? And if I have a diameter this way, can I also do this in order to signify diameter? What do you see now? Oh, I see the right angle. So the principle is the same. Principle is the same. And with math, math is always constant. And if you can look at it like that, now it's no longer that giant. Now it's something that I can tame because it's the same principle. I have a right angle. Now, you told me the distance from here to here or here to here is the diameter. Half of the diameter is what we refer to as the radius. Very good. So, following the same principle, the size of the right angle, if I want to find the area of a circle or cylindrical object, then I know I will be multiplying my right angles, sides, which would be radius times radius. Now here's the catch. I have an innie here, I have an outie here. So how do I account for the fact that this is inward and not outward? How do I make that leap? The distance around the circle is the circumference. And the circumference divided by the diameter, no matter how big or how small your circle is a unique number that is the exact same number for every circular object. Pi, very good. 3.1416, how far can you go?
For practical purposes,
3.1, that's enough, that gets the job done. It's an infinite number, that there's no repeating pattern in it. And because of that, again, we're taking into consideration the circumference divided by the diameter. So whenever I'm working with a cylindrical or circular object, I will always use pi. If I'm looking for gallons, I will always use the 7.48. It's sort of like the constant. So following the same format or pattern, pi times r, and as he said, pi was 3.14, will give me what? What will be my units here?
The square foot.
Square feet, right.
There's some in the book that we get for the test. They use 0.785.
Oh.
So sometimes it gets confusing. Like, it's
It
the
can-
same thing.
Right.
Some people
It's a different formula. And do you know where they get the 0.785 from? Okay, use your calculator for me. What did we say pi was? 3.14. How many quadrants do we have in a circle? 4. So do the 3.14 divided by 4 and tell me what you get. Oh, so that's a constant if I'm going to utilize diameter. So there's an alternate formula. Excellent. Thank you for pointing that out, Greg. So I can use diameter squared times the 0.785 also. So that is an alternative. And you know what I would do on an exam? I'd work it both ways. Every math problem you should come out with 100. Why do I say that? You should get every math problem right. Why? Yeah. You hate math? They give you the math. Remember, they give you the formulas, and you have all the answers. Are all your questions multiple choice? Yeah, so even if I don't know which way to go, I'm plugging in every number into those formulas until I get the right answer. That takes time and patience, so we need to grow a little of that. How much time do you all have for your
I think it's 4 hours.
4 hours?
3 hours?
Okay,
9 to 12.
Yeah, 3 hours and 100 questions.
okay, not bad. Can be done. All right, math is easy. Math is easy. Consistency. So we learn the principle, we stick with our roadmap. So what is the volume of a circle or a cylindrical object? We're adding now what? Height or depth. So we have pi times r times, we'll put depth this time, times depth. You want to make sure all your units are the same. No units here associated with pi. So now we have cubic feet. And notice I've written it like this here. I've written it like this over here just to show you it is one and the same. But depending on what book or reference you're utilizing, they may use the different connotations. Okay? For gallons, same principle. How many gallons are in a cubic foot? 7.48. Well, this gives me my capacity here. R times depth. And the only thing that I've added is 7.48. Likewise, with detention time, already have gallons divided by a flow rate, and I'm ready to plug in and solve. Once I have my roadmap, it's just a matter of plugging it in, making sure my units are what they should be based on the formula, and solving. So let's put it to the test. If you will, go to page 19-4. And since we have a small board, let's do this. I'll do the writing, so I won't ask you all to come up here as I normally do, but that means you all do all the calculations. And I simply write what you tell me. Deal? Just not getting any
That
help.
won't turn out.
Yeah, mine's dead too.
I can use this one.
Okay, excellent, because you're doing the work. All right, we're on page 19-4. First problem, what is the surface area of the bottom of the rectangular storage tank, 10 feet long, 5 feet wide? First question is, what shape do we have? Rectangular. Second question, what are they asking?
What's the surface area of the
Surface area. Do we have enough information to determine which formulas that we're going to use, or formula? All right, which formula? Area, where? Which one? Length times width, super. So once I've identified the formula, then all I need to do is what? Plug in. What's the length? 10, super. What's the width? 5 feet. So I have 10 feet, 5 feet. Do I need anything else? No, I can solve. So 10 times 5 is 50 what?
Square feet.
Square feet. You gotta make sure you give them the right units. I've seen some exams, they'll say 50 square feet, 50 cubic feet, 50 yards squared. So make sure that you multiply your units and give them the right units. 50 square feet. Questions? Like taking candy from a baby. And for any of you all who've ever taken candy from a baby, that may not be so easy sometimes. Excellent. Can I get someone to read number 2? And everybody doesn't have to read at the same time. Go right ahead, Mr. Rich.
How many square feet is the roof of a chlorinated room? 8 feet square.
Super. What shape? Square. What are they asking?
square feet?
They're asking for square feet. What's given?
It's 8 feet on a side.
Excellent. Because it's square, so they're all the same. So which formula? Length times width. Plug it in. 8 feet long, 8 feet wide. $64 what? Square feet. Excellent. And I love what Greg is doing. He's drawing his pictures. Do that. If it helps, draw those pictures so you can see. You'll have that visualization there. Excellent. Excellent. All right, number 3. Can I get a volunteer?
If the trench is 50 feet long and 6 feet wide, how many square feet will the bottom cover?
What shape? Same formula again? Absolutely. So our length is 50 feet long, and it is 6 feet wide. So 50 times 6 is 300 feet times feet, square feet. So 300 square feet. Excellent. Any questions? They're like, okay, oh, too easy. Number 4, what is the surface area of the bottom of a circular storage tank 20 feet in diameter? What shape? Circle, very good. What's given?
Your diameter.
The diameter. And what are they asking us to find?
They want the surface area.
Surface area. So which formula am I dealing with?
You're doing the pi r squared.
Pi r squared. Very good. Now we see we got to do a little more work than just plugging it in. So here I'm going to draw my little figure. I have a circular tank that is, what was the diameter?
20 feet.
20 feet. But when I go to plug it in, do I have a diameter? No, I need the radius. How do I find the radius?
Divide by 2.
Super. So my diameter, 20 divided by 2, gives me a radius of 10 feet. Do I have enough information now I can plug in? Absolutely. Pi is 3.14 all day long, every day of the week. And we just cut it off to that. Times 10, times 10. 10 feet, 10 feet. So what is our answer? 314 square feet. Super. Any questions?
I believe that's 3,100.
You got 3,000?
You get 3.14.
Uh-huh.
Should go to 31.
Super. That 0.14.
Oh, okay.
Put the decimal in. It should work for you. All of these are dead.
Did you get Texas Instrument one?
What does it come to?
314.
Estimates around the company.
Oh, yeah.
Yeah, it's not Texas A&M. Excellent. Any questions?
We can ship some down.
All right, appreciate that. All right, can I get someone to read the next one?
What is the surface area of a 35-foot diameter circular roof covering a service center?
Super, what shape?
Circular.
Circular. What's given?
The diameter.
And what are they asking for?
Surface area.
So, which formula?
Pi r squared.
Pi r squared again. So you're seeing how that once you've identified the formula, it's just a matter of plugging it in when you have the right units. So they give us diameter, and our diameter is 35. So 35 divided by 2 is, excellent, 17.5. So now we plug it in. 3.14 times 17.5 feet times 17.5 feet. Ooh, I got 961.625 confirmation. Sounds good? Excellent. Everybody got that?
I tested it, but it's 962.
They may indeed round up. That way they'll ask you what is the approximate square footage. So you just make sure you're close to whatever they have. All right, the next question. Can I get someone to read it?
How many square inches in square feet is the end section of a 6-inch pipe?
Super. What shape do we have?
Pipe, so circular.
Are all pipes round?
Yes. Most
They
of the
should
time.
be. Now they are anyway?
They are in this class.
Okay. So all pies are round. So we have a cylindrical object. Right. What are they asking for?
They want square inches and square feet.
Oh, now I need 2 answers. So you need to make sure when you're reading, you recognize what's being asked. Super. What do they give us?
Well, they know the size of the pipe.
Size of the pipe, which is 6 inches. So if they're wanting square inches and square feet, and they give us inches, where do you want to start? What do you want to find first, the inches or the square feet? Square inches or square feet? Inches? Okay, simple. All right, so we have a 6-inch pipe. We'll start with inches. 6 divided by 2 is, so our radius is 3 inches. We can plug it in. Pi is 3.14 times 3 inches times 3 inches gives me how many square inches?
98.26.
I heard a 28.26 square inches. Can I have confirmation? 28.26 sounds good to everybody? It's the cold weather.
28.26.
Super, super, super. Excellent. Finally, it's what it's all about. Because if you can get this down, you can tackle the other math. Every time we're building tiny building blocks. Where do I go from here? How do I find square feet?
You gotta convert feet to inches.
Have to convert feet to inches. Inch.
Feet, I mean,
Square inches to square feet.
but you have to know how many square inches it is in a square foot first.
Oh, and how do I find that out?
Easy, square foot, that'd be 12 times 12, 144 square inches in a square foot.
Okay, y'all just want to just jump right off the cliff. Very good, very good. If we were converting inch to feet, we would divide by how many inches are in a foot? 12. And as Neil pointed out, but I have square inches here, and I want to convert to square feet. And so if there are 12 inches to a foot, then we're looking at 12 squared. Principle is the same, which is 12 times 12. When we're dealing with the exponent, we multiply the base number, the number of times that it's raised. And that gives you the 144. Robert did get it first, but I quietened him down when he said 144, so I'll have to give him the credit for it. So at this point, I can do one or two things. I can simply take the square inches and divide it by 144. I've made the conversion. Okay. For others, if you want to go back to the headworks of a plant, since this is water, I can go back and I can convert my 3 inches into feet by doing 3 divided by 12, and 3 divided by 12 is 0.25. So I can go back and say 3.14 times 0.25 times 0.25, and that will give me square feet. I'll write it where it makes sense, because I'm not using the volume right now. So essentially, I'm doing that, converting inches to feet. We divide by 12 because there are 12 inches to a foot. So then 3.14 times 0.25 feet times 0.25 feet. And when we get to conversion, I'll actually show you where you can cancel your units out. So I'm still waiting on the answer, which is 0.196. That sounds good. Super. Excellent. Do number 7 for me. That one's yours to do. Tell me what to do. Someone read it and walk me through it. Who's the brave soul?
Square feet is the intersection of 18-inch pipe. So pi r squared,
Okay.
pi times 9 times 9.
Where'd you get the 9 from?
That's the radius.
Super.
And then you divide the 9 by 12, which would be 0.75. So it'd be 3.14 times 0.75 times 0.75.
I got 1.77, call 1.77.
1.77 confirmation. Super. 1.87. Huh? 1.76, 6666666. Yeah. Yeah, and so again, if you're employing rounding, that's okay. Now, he could have at this point continue with the 3.14 times 9 times 9, but remember, if you go that route, you must convert in the end. Okay. All on the same page? Okay, super. That's okay, that's what your coworker is for.
So there's 2 of us, so who's working?
There you go. You know what they always say, 2 heads are better than 1.
Unless they're on the same body.
All right, excellent. Number 8. How many square inches are in the end section of a 24-inch pipe? Which way do you want to go? That one's easy?
That's firehouse head is, 12 times 1 times 1.
12 times 1 times 1?
Yeah, because you got the square, so
3.14 times 1.
That's what I meant.
He's doing what I'm doing. When you work so fast, absolutely. Where did the 1 come from? Remember, it's a 24-inch pipe. So that's my diameter divided by 2 gives me a radius of 12 inches. Then we convert to feet divided by 12 inches per foot gives me 1. So what's the final answer? 3.14 feet squared. And number 9. How many square feet is in the end section of a 36-inch pipe? So my diameter is 3 feet. So you've already converted it. He took the 36 inches, divided by 12, got 3 feet. And now I need to get a radius, so I'm going to divide that by 2, and I get 1.5 feet. Now it's in a form I can plug it in. Pi is 3.14 times 1.5 feet times 1.5 feet gives me how many square feet? 7.065 is what this side. Confirmation. Excellent. Are there any questions on area? Would you agree this was very simple? So we can step it up a notch, right? Not a problem. Excellent. All right, the next section deals with volume of a rectangular box or a cube. We've already gone through the formula for that, so turn to page 19-8, and let's keep rolling. What happened to our volume? Remember volume. If I'm working with a cylindrical object, it's pi times r, and you can use pi r squared, that connotation. I like to write it out so you can plug a number in with every letter, times the height or depth will give me the volume in cubic feet. If I want gallons, I multiply my cubic feet times 7.48. Problem number 1. How many gallons of water will a 20,000 cubic foot tank hold? So what's given? What's given? Cubic feet. Super. And they're asking us to find gallons. So if we have cubic feet, which is this component here, already been figured for us, then what do we need to do? Multiplied by 7.48. So we have 20,000 times 7.48. So I have someone who said 149,600 gallons. I need confirmation on that number because I don't have a calculator. Excellent. It is correct. Is that what you get?
What was that?
149,600.
Yeah, I could read, I can partially read it. That's it is.
It's two, that's what it is?
Yeah, 149,600.
Super. Excellent. All right, number 2, please, if someone can read it.
How many cubic yards of dirt are removed from a trench 60 feet long, 5 feet wide, 5 feet deep?
So what are they asking us to find?
Cubic yards.
Cubic yards. Have we talked about cubic yards yet? No, we haven't. So how do I find cubic yards? Based on what so I'm going to start with feet. Okay, super. A yard is how many feet? 3 feet. And if I want cubic, Earlier I found out cubic meant what? If there are 3 feet, cube means to raise that. So that means 3 times 3 times 3 gives me 27 cubic feet per what? Cubic yards. Excellent. I'm going to need that in order to convert. Okay? So, based on that, let's plug in. What shape do we have? Rectangle. So I'm on this side, right? Excellent. So what's my length? 60. What's my width? What's the height or depth? Super. And so that gives me cubic feet. $1,500 cubic feet. So if I have 1,500 cubic feet and I want to go to cubic yards, want to get rid of cubic feet, I'm going to write my conversion factor in here. Let me explain this. Too much going on here now. When I want to convert and show my work, to show my units, to cancel out, if I were to put 1 over 1, what does that give me? 1. 2 over 2. 3 over 3. So when we want to cancel out, we simply put that unit over itself. When I am solving and want to show my work, I always start by putting a big plus sign on the paper. Always write what's given in this first quadrant. And so where we ended up was 1,500 cubic feet. That was the unit that was given. I want to get rid of cubic feet, right? So I'm going to put it on the bottom, because when I divide cubic feet by cubic feet, cancels out, giving me 1. Any number times 1 is that number, right? What are they asking for will be here, cubic yards. Now I will go to my conversion chart and find the relation between cubic feet and cubic yard. We did it up here earlier. How many cubic feet are in a cubic yard? So this is a number that I don't have to memorize. I simply write down from the conversion chart. This is what I'm given. This comes from the conversion chart. Okay, cubic feet will cancel out. Now here's the catch. Vertical lines tell me to multiply. And it will be the same consistency throughout the math lesson today. Whenever we see vertical lines, when we start dealing with pounds, we see a vertical line. It tells you to do what? Multiply. What do you think the horizontal line tells you to do? Divide. Doesn't it look like a division sign? Yeah? Super. So 1,500 multiply across times 1. If I'm going down across this line, divided by 27, that gives me how many cubic yards? 55. Okay, and I need confirmation on that big long number. Super. Yeah, I can't take his because he's sitting right next to him. So they're teaming up back there. One's putting it in. The other one's just giving me the thumbs up. I think I got it down pat now. Super. Can I get someone to read the next one?
Rectangles, large tank is 25 feet wide, 40 feet long, and 10 feet deep. What is the volume in 2 feet and gallons?
All right, excellent, excellent. Now I erased all the formulas because now I want you to tell me the formulas. They've been up there a while, you got them up there, right? Super. What are they asking for?
Well, you got to know the volume first.
Volume in
Feet and gallons.
in cubic feet. What shape do we have?
Yes. Rectangle. I'm sorry, it's a rectangular.
How do I know it's a rectangle, not a circle? Oh, because it says rectangle. I can't go with storage tank because the storage tank can be circle, but I'm looking for key things. Is there a length? Is there a width? That'll give me, it's a plane object. If they give me diameter, I know what? Even if they don't say circular, it's circle. So what is the formula for rectangular object for cubic feet? Excellent. So plug it in. What's the length? What's the width? What's the height? And it's feet. So that gives me how many cubic feet? And I heard more than one, so that must be confirmation. Now, to go to gallons, because that's the other request, I have cubic feet times 7.48 converts it to gallons. So how many gallons are we working with?
74,000.
Questions? Easy yet, Greg? Greg was the one who said,
It's okay right now.
it's okay to say it's easy. He's like, even though I've never agreed in the past, I'm still holding on to that. Yeah, I don't want to let it go yet. I don't want to admit that, wow, this is too easy. When are we going to get to the hard stuff?
Because you'll ask me a question. I don't know.
It's all about repetition. What color is that shirt you have on? What color is that shirt you have on? What color is that shirt you have on? How long did it take for mom or dad or pop to say that to you how many times? It's about repetition. The more you do it, the more you develop those muscle memories, with actually punching it in, it becomes easier and easier and easier. You'll be thinking about it in your sleep. You'll walk into that exam without a problem.
I'm good for the exam. Teach somebody else how to take an exam now.
There you go, and that's what we want to do. Each one teach one. What you learn, you pass it on and show others how easy it is. Next one. Rich like, I'm not buying it yet. All right, who's got the next one?
Calculate the cubic yards of dirt removed from a trench 2,000 feet long, 4 feet wide, and 6 feet deep.
What's my formula?
Times width, times
Okay, and why did he say that? Because it's what shape? Rectangular. That gives me cubic feet. Am I where they want me to be? No, because they're asking me to find what? Cubic yards. So I need to go an additional step. You want to make sure you end up exactly where they want you to be. So if I have length times width times height or depth giving me cubic feet, what else must I do? Convert it to cubic yards. Okay, excellent. And remember that conversion. And what you'll find out, and you won't have to go through all this process once you've done it enough, it will be just dividing it by 27 cubic feet per cubic yards. Cubic feet will cancel out. You don't have to do this every time. All right, what's the length?
2,000.
Width? And the height or depth? Divided by the 27 cubic feet per cubic yards. Cubic feet will cancel out, leaving you with cubic yards, which is where they want you to be. I heard. Okay. Can y'all agree that essentially the numbers are the same that you just gave me? So again, it's up to you whether or not you round or not. Excellent. The next one, please.
Find the volume in cubic feet and gallons of a clarifier 60 feet in diameter and 12 feet deep.
What shape?
Cylinder.
Cylinder. Excellent. What's my formula? Is that all they want?
No, they want the volume, cubic feet.
Excellent. All right. What is the diameter?
60 feet.
60 feet. But I need a radius. So 60 divided by 2 gives me 30 feet. Okay, now I can plug in what is pi? Radius is 30, and the height is 12 feet. That will give me cubic feet. Feet times feet times feet. And it is 339.2.
33,912
Say it again.
33,912 cubic feet.
Okay. That look about right?
Yeah, that's right, the point.
Yeah, that decimal on that calculator couldn't half read it where it was. All right, excellent. That's cubic feet. So in order to get gallons, how many gallons are in a cubic foot? Super. And that gives me how many gallons? 662. Excellent. All right. So, number 6, table 1. You all are now designated as table 1 over here with Dan, Norm, Robert. You're table 1. You all have number 6. So I would like you to work it, and then you all will tell me what to do up here. Number 7. Excellent. Rich, Dave, you all have number 7. Number 7. I don't have that many. Number 7. Number 8, Neil. Number 9. So, yeah, whole table has number 7. I kind of ran out. So, talk amongst yourselves, come up with an answer, and then let's see what you did. And then let's do this. Take it a step further. You all can designate someone to come to the Board of Honor to write it up here. You know, out of all the classes, this is the only time that I probably tell students they can work together and it goes solid instead of the talking. The other time it's like, all right. And if you need any directions, just look up. Ask yourself what shape. Identify the formula. Plug it in. Shape. Formula. Plug it in. Once you've completed, you can go up and start writing it down.
You gonna write it down? Jeez.
What you come up
Do we
with?
actually have the answer to, or do you care?
Is that the answer?
Yeah, we
You
got
want to rethink it?
You got this one here.
Uh-huh.
Radius of 3 feet.
Huh? Give me some dab. He caught it. He caught it. He caught it. You put a little too much in it now. You were on the right. He caught it. He said a radius of 3 feet. But it's a radius.
Right.
So I'm not going to cut it in half because it's already in the form that I needed. It's a
So I was
radius.
right the first time.
So pi times r times r,
So I had 81, so I had 81 cubic feet
okay, times, how do I convert it to gallons?
times 7.48
48, excellent,
divided by 4.
excellent. See if you come out with the same answer. What you just said was perfect. Okay. How we doing? Okay. So what's your formula? Excellent.
3.14 times R times R times the feet.
Right, times the length. Excellent. So now plug it in. Yeah, it's 6 inches. So that's your diameter. So
3.14.
convert it to feet first because this is in feet. Remember, you can't multiply apples and oranges. So I have 500 feet. I need to convert 6 inches to feet so I can have feet and feet. So how do I convert inches to feet? How many inches are in a foot? 12, super. So 6 divided by 12. You know it. 6 divided by 12. A half a foot is 6 inches, right? 6 inches. A half a foot, so 0.5. Literally put it in. 6 divided by 12. You're flipping it. Okay. Yeah.
3.14, the formula,
Right?
times 0.5.
0.25, because now I have to divide it by 2 for the radius. So times 0.25, that's your radius, times 0.25, times the 500 feet length, times the 7.48. That's your game plan. Times 0.25, did you do it twice? Yes, times 500 feet long. And now I need to convert it to gallons.
Times 7.48.
Excellent. So what you get? Did you plug in them?
What do I get? That's what I get? I can't read it. 5?
Okay,
Is that a 5?
yeah.
5.6.
These calculators
I know.
must be cold, because they're usually not this difficult. Ah. Can calculators get too cold? Yeah, because I'm about to get frustrated. Okay, so we have 3.14 times 0.25 times 0.25 times 500 times 7.48. I think that's your better bet, is to just use that. But if you write the formula every time and plug in, you won't go wrong.
This is a little fast, because I've never
It's
done
too fast? Okay,
Well,
we'll
I've
slow
never done
down.
anything, but you know what, it's okay, because I'm still
Okay.
getting something out of it, and then time I
Okay,
can do it again and get it.
excellent.
I'm gonna slow you up, but I,
Rich, I'm kind of challenged with my eyesight, and your numbers are getting smaller and smaller and smaller and smaller. Okay, that's what I need to do. How's it going over here? Got it going on? Which one did you all? Okay. Diameter, super.
Well, to move up in the ranks to get more money, you have this. They only really require as high as a 2 treatment. You don't have to get a 3 treatment, but they want a 3 distribution.
So how are your license here? Are they all separated from the way you all are talking it is?
We're treatment only,
Okay.
because we don't deal anything with the distribution.
So does your treatment license allow you to work in the distribution system?
We work inside the building, that's it.
Okay, interesting.
And then there's another, there's a small systems.
Mm-hmm.
And I think that's like, I don't know what that can cover, but there's a lot of people that take them, like, and I don't know
Well,
what-
the Navy might have
I
a
think,
small one
yeah,
that treats.
like if you work for rates, like if you work for like a high school, like a private school or something, and have their own system.
URI. URI
Yeah,
actually has
is
it, yeah, they have a small.
you would
Yeah,
go
and
for
that
a
will be
small
like
system.
the
I don't know how.
non-community system that Jack was talking about earlier.
Yeah, something like that. And the funny thing is like going for your, when you go for year 3, at least I found, most of our information I found in the small treatment study guide.
Oh, really?
I don't know
Okay.
why, but when I read even Steve Boudreau, he gave me that big book, it was a small treatment book, and it had all the
So that could be an
The rules and
excellent,
regulations.
excellent source for you to study from.
but like he
So
was-
far, so good.
You go and study one thing, and then you go and take the test.
And then you focus on that stuff, and then you get different.
So do we have a volunteer from this table to put it up there?
They're not very friendly.
They're not.
I mean,
You know, it's ironic, but regardless of which state you're in, we all feel that way.
they don't try to, like, I go to a lot of these things through either Atlantic States or New England Waterworks, or this is the first time for you guys. And all of them, it's like, why don't you, if the test is the most important stuff that we're supposed to know, why would you not, you don't have to teach, you don't have to say, hey, question number 2 is gonna be this, but you should teach the stuff that's gonna be on there. Because there's guys that have been in our plant for 30 years, they wouldn't pass the test right now, because they don't know that stuff, because they've never taught it.
I'm not sure how it works here,
I mean, they know it, but not like,
but as an operator, all the rules and regs, that's where we're supposed to be getting our information, our knowledge from anyway, to study, to pass the exam, and that's where you need to focus. What we've done in most of these books is try to consolidate that information, but as an instructor, we may not hit on all those important points, so.
But here, what a
our study guides didn't even have the safety drinking water app. So they're like, here it is online, and you like scroll, there's no way.
Yeah.
the
I'll tell you
information's
what.
so spread out, it's.
Call Texas A&M back to provide you with your
But
training.
like the question, that test thing you gave us, if that, if we had that and you took that as a practice test, you'd probably pass the test.
Yeah, okay. And if any of you all would like a copy of this upon our leaving, we'll give you one. Okay,
That would help.
one with the
Even for
answers
us,
in
like,
it.
just to refresh ourselves.
Right.
And look over it, because, like I said, I happened to take the test the old way, and we had all these practice tests. Really good on it, and I got 69, I missed our one. Then they gave us the new test, and I took it, she said, oh, just keep doing what you're doing.
Actually, I wanna go get like treatment 4 license.
I guess I took all the good ones. We'll get there.
I was lucky to pass it first time around.
I missed it by 1 point, and all I did was I had a study guide, I had 2 different study guides. I kept taking the practice test. And there was actually one question that I couldn't, I looked at it and I couldn't remember. And it was the same, it was word for word, the same as the practice. And I couldn't remember, I got 69. I wanted to keep this one. So then I called up and said, can you send it, since you're getting a new test, can you send us new practice quizzes, new study guides? And she said, it's the same. And I went from a 69 to like a 58. I'm like, it's not the same. And I kept arguing with them. Like, yes, it is. I'm like, no way. There's 20, we didn't have all these questions on the safety of water drinking. Like you would say, the copper and lead rules, and we don't, there was a lot of questions where our lab people might know,
Yeah.
because like, the first thing.
It's in the rules. That's where they're going back.
We don't know that, we don't do
Right, you don't do the sampling and all of that.
Because they know where they take
The sample.
their samples from and why they take samples, we don't know that.
Yeah.
It is weird.
And it all goes back to, again, what do I need to know as an operator? Although I may not be doing that on a daily basis, I am still bound to be aware of the rules and regs and so.
Before you, a lot of the problem I believe in our system is the guy that used to run our lab, which you probably know who he is, Hugo. He's up
Oh, isn't Matt or
Hugo. Yeah. He ran our lab. Now you go and ask him a question, he would never answer you. Now his assistant now is the head of the lab. Now she is basically giving us all this information, and her assistant it's like going through school all over again. But now we're starting to learn their side, their what they do. And so we're starting to actually more work as one than versus three different distribution labs and treatment.
Okay.
Now it's starting to actually come together, which is nice. It's like
All right, let's look at them. Look like that you all are all in line. On number 6. Number 6, we have a sedimentation tank 55 feet diameter, 12 feet deep. What is the volume in gallons? Can you all tell us what you did? Yeah.
The radius, square the radius times pi times 7.48 gallons. Total number.
Okay. Times the depth, absolutely. So the final volume in gallons, 213,146 gallons. Okay. Questions on that one? Again, write the formula down, go back, plug it in. It's all about practicing. Where did they get the 27.5 from?
Divided by 5 by 2.
Super. They took the diameter and divided it by 2 to get the radius, because the formula calls for the radius. Okay? Excellent. Who had number 7? If you can read it and tell us what you did.
Chemical mixing tank, 15 feet square and 15 feet deep, will hold how many gallons of alum? It's 15 feet square, that's 15 feet on a square. It's actually a square, 15 feet on either side.
Okay, super. So I have 15, 15, 15. Excellent. You can go ahead and walk me through.
And so it's 15 feet times 15 feet times 15 feet. That'll get you your cubic feet, 3,375. And then to get it into gallons, you multiply by 7.48 gallons per cubic foot.
Super.
And the cubic feet cancel out and you end up with gallons. 25,245 gallons.
Excellent. Questions? None. Super. Number 8. Welcome.
The question is, a bleach tank has a radius of 3 feet and is 9 feet deep. How many gallons will it hold 1 quart full? First thing you notice is this is the first time they've mentioned radius. And so you don't want to divide that by 2. So our radius is 3 feet, so you multiply the 3 feet by 3 feet. And the tank is 9 feet deep. But then it also asks you, 1 quarter full, so that's why we took the 9 foot divided by 4. And then multiply that by pi, it's 3.14. So we ended up with, multiply that by 7.48 gallons. We ended up with 475.6.
Excellent. Point. If you write the formula every time, I know it seems redundant, if you write the formula every time, that lessens the possibility of you going astray. And if you read and make sure that you read with understanding. They did the exact same thing that I did when I first approached this problem, because I was so used to, all right, everything is already in diameter, divided by 2, divided by 2. So that was a good catch there that, hey, no, that's the radius. But because the formula is written, it sort of gives you a guideline to keep you on the straight and narrow. Okay. All right, number 9. If you can read it, walk us through it. You want to write it? Or you want me to write it? Come on up and have your 5 minutes of fame. Excellent. Want to walk us through it?
How many gallons of 500 feet of 6-inch water pipe will hold? You have to change the 6 inches to feet, correct? So you have to, let me see, when we get that, multiply that times 2.
Okay, so what you're doing first is finding the radius. Super. Okay, I can go along with that.
Divide the 6 by 2,
So I have 3 inches now.
all right, and then
Convert that to feet
convert that to feet,
by dividing it.
divided by 2 again.
12.
I'm sorry, divided by 12.
Right, because there are 12 inches in a foot.
Inches in a foot.
Super. So that gave him the radius of 0.2.
Yeah.
And then at that point, you just,
You gotta take use your formula
excellent.
and multiply it like it is, and then you get your 500 feet times the 7.48 gallons to get the answer.
Excellent, excellent. And I know it feels kind of strange. I do applaud you all and thank you for your class participation, but actually walking through it and verbalizing it, it kind of helps to lodge it up there also. So you all are very brave. Appreciate that. All right, go to page. I'm going to skip over conversion factors for right now, and I want to hit the dosage. 19-4. Since today we dealt with, and we'll come back and get it, we'll probably still have time, but I want to focus here first. 1914. Yeah, 19-14. Yes, sir. Oh, you were listening. Very good. Today, Jack dealt with disinfection. And it's very, very critical to make sure you are adding the correct amount of dosage in order to clean the water up. So now we are dealing with those bacteria, viruses that are susceptible to chlorine that will nullifying them, right? Right. Okay. Can I add too much chlorine since we're talking dosage?
Yeah.
I can. And if I add too much, then what happens?
Cemetery's gonna be full.
Oh, yeah, because now we're producing all of those disinfection byproducts. So it's very critical for us to control the amount of chemicals, make sure we have adequate amount, and the EPA says adequate amount, at least a 0.2 or a 0.5 residual if you're using chlorine, or you look at whatever disinfectant. He's using chlorine dioxide. So with his deal, it's a maximum that he cannot exceed. So you want to make sure that we have control of the proper dosage. Earlier, Jack said dosage was what? What is dosage? What was dosage? The amount that is added. That's all dosage is the amount that you're adding. And he gave you the chlorine demand curve where you're just continuously adding. So the amount that is added is the dosage. The amount that is used up, think about stage 1. The amount that is used up by reducing agent is the demand. And what he pointed out earlier, stage 1 to stage 3, that's your demand area. So I have dosage, the amount that's added. Demand is the amount that's needed in order to reduce those pathogenic organisms or used up by a reducing agent. So what's left over? Residual. And that's how we know that we've accomplished what we set out to accomplish, is by having that residual. That's very, very important. So the amount added minus the demand will give me residual. Dosage minus demand equals residual. Demand plus residual is equal to dosage. Just seeing if you're checking, if you're listening with me. Dosage minus residual equals demand. There you go. Very good. Very good. Very simple subtraction, addition on that. Now, for pounds, then we have to take into consideration not only the dosage that's applied, but how many gallons we're working with. Our pounds formula says, do I need my water gun? I heard some, Rich, was that you yawning?
Let me just scoot away, please.
Yeah. All right. So for pounds, I need to know a flow, okay? And usually the flow for this particular formula must be in million gallons per day. That is the unit that I need my flow in. So I have flow times the weight of water, 1 gallon of water, because we're not looking at any solids, and hopefully in water we don't have that issue with the added solids and everything, because turbidity is not a problem, because we're keeping turbidity to what if we have a surface plant? Less than 0.3. Super. So how much does 1 gallon of water weigh? 8.34. Excellent. Times the dosage, which is milligrams per liter. Should put that milligrams per liter there and dosage up here. That's the amount that is applied, okay? And that will give me pounds per day. Pounds per day, okay? 8.34 is the constant for this particular one. So as long as they're asking me to find pounds per day, all I need to do is multiply across. Suppose they ask me to find flow, or they ask me to find dosage. Then what do I do? Well, there's, and I think this is in your book, this little, or is it? It's not? All right. We set up this little diagram to kind of help us out, where we don't have to worry about rearranging or going back to Algebra 101. What you do to one side, you got to do to the other side to keep it balanced. So this, I found out, was very, very, very good. Excellent. Top half is equal to the bottom half, okay? So I'm looking for pounds per day. And our vertical lines told us to do what earlier? Multiply. Very good. Man, Rich's been listening. Our horizontal lines tell us to do what? Excellent. So I'm just going to put this in down here, my flow in MGD, the other parameter, 8.34, and milligrams per liter. So the way this works, so I don't have to worry about rearranging the formula, if I'm looking for dosage, simply cover up what you're looking for and perform the other function. So if I cover this up, my formula has already been rearranged for me. Pounds divided by flow times 8.34. If I'm looking for flow, cover it up. That's my formula now. Pounds divided by 8.34 times milligrams per liter. If I'm looking for pounds per day, multiply across, the remaining is my formula. So I don't have to worry about moving something to one side, doing the same to both sides. So excellent in helping to break that down. So for the most part, if we have gas chlorine, it's 100%. And if I'm looking for pounds, all I have to do is plug it into the formula. But suppose I have HTH. What percentage of purity was HTH? You learned that earlier today? About 65%. Did a great job. Very good. You remember, that's right. That's what it's all about, 65%. So, question. Will I use more of something that's less potent, or do I use less of the less potent compound in order to achieve the same result? Why am I using more? It's not as strong, absolutely. So, how does that affect this formula? If I'm using less, it's not 100%, I can still use the same formula, but now I'm dividing it by the percent purity. So I still have MGD times 8.34 times milligram per liter, and if we're dealing with 65%, the decimal form would be, if it's 65%, remember we take that and move it 2 places to the left in order to change it to a decimal, so we will divide it by 0.65. If it is a bleach solution and it is 5.25%, then I'm going to take this and move it how many places? 2 places in order to change it to a decimal, and I would divide it by 0.0525. Okay? And use every case it'll be at a little more. All right, let's work these. Problem 1. A sample of treated surface water has a chlorine demand of 3.5. If the operator wants a residual of 1 in a clear well, what dosage must he apply? So what do they give us? The demand and the residual. So if given the demand and the residual, how do I compute the dosage? I add them? I guess that's what I heard. Super. I just didn't add them, absolutely. The demand, 3.5. Residual, 1. 3.5 plus 1 gives me a dosage of? Excellent. All in agreement? It is just that simple. And I don't know how they are here, but in Texas, I think it was a B-level question. They gave us one as simple, but they put some more information in there. Whereas you start trying to use every other formula, keep it short and simple. Give them what they're asking. Nothing more. Definitely nothing less. Number 2, an operator applies a chlorine dosage of 2.75 to 5,000 gallons of well water. Chlorine demand of the water is 1.25. What will be the milligrams per liter residual? What's given again? Dosage. Demand. And I want the residual. So dosage minus or plus the demand is equal to the residual. Which one? Minus. Very good. Dosage minus the demand is equal to the residual. What about the 5,000? Yeah. Ancillary information to make me want to do what?
So you take the dosage minus
The demand. That's it. That's the answer. So 2.75 minus 1.25 gives me a residual of 1.5. So in this case, we make sure that we do not allow human nature to take over and try to stick that 5,000 in there to multiply it or do something to it. Stick with the formula. Dosage minus demand equals residual. Questions? Number 3. An operator applies 7 milligrams per liter of chlorine to well water containing hydrogen sulfide. The hydrogen sulfide reacts with all but 2.5 milligrams per liter of chlorine. What is the demand? What do they give us?
You gave me the dosage.
Dosage, super.
And they gave you the residual.
Excellent. How do I know it's the dosage?
That's what he applied.
Applies, very good. How do I know that it's the residual?
It says, because it says the sulfide reacted with all but 2.5 milligrams.
And that's the way I want you when you take those tests, analyze it like that, talk to yourself. Don't leave yourself hanging. Make sure you answer yourself when you talk to yourself. So, dosage minus residual equals what? Demand. So what's my demand? 4.5. Excellent. Altogether, does it make sense? Yes, no, maybe so? Kind of, sort of, getting there? Okay. Repetition, repetition, repetitions. Love number 4. After flushing a hydrant for 10 minutes at 200 gallons per minute, a water sample shows a chlorine residual of 4.8. If the chlorine demand is 2.2 milligrams per liter, what is the dosage? Where do I start?
Well, for one, throw off the flushing bit. That means nothing. All you're concerned about is the residual and what the demand is.
Excellent, because all they're asking us for is what? The dosage. They're asking for the dosage. So the dosage is demand plus residual. It does not matter whatever they throw else at you, demand plus residual. So what is my demand? Excellent. And what's my residual? So what's my dosage? Excellent. 4.8 plus 2.2. All right. Any questions so far? None? Number 5, the following alum dosage were applied during the surface treatment, water treatment. 5 milligrams per liter from midnight to 6 a.m., 30 milligrams per liter from 6 to 10, 25 from 10 to 6, 15 from 6 to midnight. And they want to know what is the average dosage per hour for that day. Now, when they give us instructions on how to compute it, make sure you follow what they lay out for you to do. And so in this case, they say multiply each dosage by the hours applied, then you add the numbers and divide by 24 hours, because there are 24 hours in the day. So, from midnight to 6, how many hours is that? 6 hours. So 5 times 6 is 30. From 6 to 10 is how many hours? 30 times 4? 120. Excellent. From 10 to 6 is how many hours? 8 times 25? 200. From 6 to midnight, how many hours? 6 times 15? 6 times 15? Is that all of them? Excellent. Let's add them all up. Am I missing one? 1, 2, 3, 4. I'm missing one. 1, 2, 3, 4. Oh, it's only 4. Excellent. Add them up. What'd you get? 440. How many hours are in a day? So that gives me an average of what?
18.3.
Oh, who said that? Jack, give him a dap. Give him some dap. Jack? Give him some dap. I'm not that close. Very good. Very good. He was on that one. Very good. All right, now we're getting to the real problems where I was trying to get. 6, a surface water treatment plant produces 1,600,000 gallons per day using alum, 9 milligrams per liter dosage. How many pounds of alums are used per day, per hour, per 30-day month? Great. Now we get an opportunity to utilize our formula. First of all, I've said, write the formula. This is the pounds formula. You write the formula, it lessens the opportunity of going astray. So I have MGD times 8.34 times milligrams per liter. That gives me pounds per day. Now that I've written the formula, identified the formula, what's given? Let's plug in what's given next. What's given? Okay, so how many gallons?
1.6.
I heard 1.6. Is 1.6 given?
Yes.
Is 1.6 given? That's someone who's ahead of the curve. Very good. He made that conversion. Actually, 1,600,000 gallons. And what I want to point out is that this is not the same unit that's here. And with these formulas, you want to make sure that you have the unit that's in the formula. So you need to convert. You need to convert gallons per day to million gallons per day. How do I convert gallons per day to million gallons per day? It's like, okay, just keep it rolling. How do I know to divide it by a million? I'm going to go back to my conversion chart, and on my conversion chart, they'll probably tell me 1 MGD is equal to 1 million gallons. If you want to put the per day, that's cool too. Okay? And so if you remember this right here again, what I'm starting with, I want to get rid of it. Gallons per day, mg. I'll just use the day. I'm not really using it. 1, and I'm going to plug this in, and because it's on the bottom, it's divided. That's one way. How many zeros are in a million? 6. So another way is to simply count over, and it's understood for the decimal to be at the end of the number when it's not in the number, when it's a whole number. Count over 6 places. 1, 2, 3, 4, 5, 6. I've converted. Okay. Another real cheesy, and I say cheesy, if I had a number that was like 5,700,000, wherever that comma makes it a million, just change it to a decimal. Works every time. Okay? So either of those ways. So, but as they pointed out, we're plugging in. 1.6 is the MGD times 8.34. What else is given? Times dosage. Again, 9.0. So if I multiply all of those together, it's going to give me pounds per day. How many pounds per day are we utilizing?
1,200.
That sounds a little better. Yeah, that was just a little, Hey, you know what I always tell people who have issues with decimal points? Let me handle your money. That will straighten him up right away. Let me handle the money for you. And when you end up homeless, then you'll start paying attention to those decimal points. Very, very critical. So 120, give or take, pounds per day. Are we finished? What else do they want us to give them? Pounds per hour. How do we find pounds per hour? Super. Why 24? 24 hours a day. So I'll take the pounds per day, divide it by 24, and that'll give me the pounds per hour. That is not thunder, is it? Okay. Excellent. Are we finished?
30 days.
Oh, I need the 30 days. So what do I do in order to get the pounds per 30 day? 120. So I have to go back to the per day and multiply that by what? 30-day month, and that will give me the pounds per 30 days.
3,602.88.
Okay. I had 3,602. Excellent. Excellent. All right, an operator using a 150-pound cylinder, chlorine cylinder, treating 5,000 gallons per day at a dosage of 1.5 milligrams per liter is the safe withdrawal rate. Vacuum transmission exceeded if the chlorinator room is 75 degrees Fahrenheit, not Celsius. What do I need to do?
You gotta figure what the usage is gonna be for the 24-hour period.
So I need to do the pounds, all right? I have my pounds formula up here. What is my flow in MGD?
It's 5.05.
5.0. Do we all understand why he said 5.0? He divided it by a million. Super. And what's the dosage?
Times 1.5.
And that gives me how many pounds per day?
£62.55 per day.
Confirmation on that number? Excellent. All right, what's the temp?
75. You got 13 gallons to spare.
Oh, how do I know that I'm okay?
Because it's 1 pound per degree.
Very good. Vacuum transmission, we're looking at, we can safely withdraw 1 pound per degree Fahrenheit. 75 degrees out, we're good. Have we exceeded it for pressure transmission? Yes? Why? Yeah, we did go over it earlier. 75 is what's given. 75 degree Fahrenheit is what's given. So what I would do is look at the 1 pound per degree 75, so I can safely withdraw 1 pound per every degree. 75 degrees tells me I can withdraw 75 pounds. And as long as I'm not exceeding that, then I don't have the issue of the freezing. 42. So I would have exceeded it.
What happens if you throw a propane heater in that, will crank up to 100, then you could,
I can withdraw more. There you go. And a lot of people do put the heaters in their chlorinator rooms. I'm pretty sure you all do that up here too, huh?
We have heaters on.
You have heaters? Mm-hmm. All right, number 8. How many pounds of fluorosilicic acids are used daily at a dose of 1 milligram per liter if a well produces 500 gallons per minute? What do I do?
Convert it to gallons per day.
Super, super, super. So,
60 minutes times 24 hours times 500 gallons.
or 500 gallons a minute times 1,440 minutes in a day.
excellent. Either or. So, 60 minutes in an hour, 24 hours in a day, 500 gallons per minute, and that gives me how many gallons per day?
306,000.
Oh, I heard 2 different numbers.
30,600.
Oh, I heard another number. Now I'm confused.
It's 720,000 gallons.
Super, gallons per day, but is that the form I need it in?
Like 5 million gallons.
Super. Okay. Okay. And do they give me a dosage? Okay. So how many pounds per day?
.00.
6.0. Excellent. Okay, cool. You got here?
No, up to 720.
720.
Got that.
All right, cool. But that's in gallons per day.
Yep.
For this formula, I need million gallons per day. So to go from gallons per day to million gallons per day, I can divide by a million, because there's 1 million gallons in 1 MGD, or I can move my decimal places 6 places, and that's where the 0.72 comes into play. So now I'm just plugging it in. My flow in MGD is 0.72 times 8.34, which is the given pounds, the weight of 1 gallon of water, times this too was given the dosage of 1 milligram per liter. So then I just multiply across and should come up with 6 pounds per day. How would you love to have a 20-hour class? Nothing but math.
I worked midnight last night. I went to 8 and came straight last night.
Oh, come on.
Just got home.
All right, number 9. Lime is used in a surface water treatment plant at a rate of 480 pounds per day. If the plant produces 2,400,000 gallons daily, what is the milligrams per liter dosage? What's my setup? Very good. Very good. All right, Paul says this is the time that we're going to chunk Algebra 101 out and just go to our setup here. What goes on top?
480 pounds per day.
Okay, the pounds per day. So the given is 480 pounds per day. What is my flow in MGD? 2.4 MGD. 8.34 is constant, so I am looking for milligrams per liter. Now this is a test. I'm going to let you work it and tell me the answer. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally.
Okay, choose excuse.
It's like, what does Aunt Sally have to do with anything? I don't know. We'll see. If anything. Let's see. And whatever answer you get, don't be shy. Let me know what you get. Did you come up with something yet?
23.9.
Okay. What'd you come up with? 0.0417. 23.98. I think there's another number too that we usually see.
23.98. What are you looking for?
Huh? I got 2 different answers. I'm confused.
Oh.
So I need someone to help me here.
Oh, we got the pounds is 480.
Mhm.
So it's the million gallons per day times 8.34 times the milligrams per liter equals 480 pounds. So then you take the 480 pounds, you divide it by the million gallons a day and 8.34. And that should leave the clear, it might be around.
So which one's the right answer?
3.98.
Huh?
3.98.
Okay, you agree with that, Norm? Y'all agree with that? Okay, y'all don't give me much to work with. You're too sharp for me. Absolutely. 23.98. How did we come up with 0.0417? Okay.
Well, until I saw that I had done it backwards.
Okay, cool. And usually there's another number because there are some common pitfalls that we fall into when doing math. There is a hierarchy of math. Please excuse my dear Aunt Sally. In other words, if I don't do math in a particular order, I don't come up with the right answer. I need to make sure that I handle anything in parentheses, please. What's the E for? Exponents, super. The M, multiplication. My D. So, multiplication, and that's what we have here. Multiplication comes before division. So what I need to do is one or two things. Complete this multiplication and simply, do another equal. 480 remains there. And when I multiply 2.4 times 8.36, 16, that should be like a 20 point something. 0.016. Excellent. Once I've done that, the numerator always go in first. And what the average person will do, they will multiply this, but then they'll put divide and put the 480 in. Your numerator always goes in first, and your denominator goes in the calculator last.
I always found it was easy to just establish what is one part first. And then you can, if it's 20 point something pounds, and then just establish what one part is, and then you can divide that by whatever the total is, and it'll give you how many doses you part.
Excellent. That's another. Keep in mind, there's always more than one route to get to that answer as long as we're at the same place at the end of the day. So whatever keeps your boat afloat, that's what you want to employ. The key is to be consistent and to do it repetitively. So always more than one way, excellent, because someone else may find that an easier way to tackle it.
I can't do long. I can't do that, and that confuses me.
Okay.
So I compartmentalize things.
Excellent. That'll work. Now, is there a way around the hierarchy of math? Are you interested in it? Yeah, if there is. There are always exceptions to the rule. So the way around it, and I won't tell you my life lessons because you'll say, okay, now she's being sexist, because I usually say your numerator represents women. Denominators represent men. In other words, this is the life lesson. If you want to live a long, happy life with your wife, you're going to make sure you open that door and she always goes first, right? Want to keep her happy? She goes first with everything. So, you want to make sure this is your wife, girlfriend, significant other. She always goes in first in that calculator. Huh? I'm from the U.S. Then, I'm telling you the opposite way. I'm trying to stay. So, if you want a guy to take out the trash, what do? And tell him to do the opposite, he'll take it out. So in order to put this in, do the opposite. Instead of multiplication, what is the opposite function of multiplication? Division. So I can do what I call a chain calculation. I didn't come up with this. This is just somebody else did. Chain calculation. I can put into the calculator 480 divided by 2.4, opposite divided by 8.34. And you're there also. All right. Either way you work it, whether you're remembering the hierarchy of math, please excuse my dear Aunt Sally, or you want to live that long, happy, blissful married life, ladies first, you'll get to the right answer. So that's my life lesson for today. Any questions?
I have to come back.
Uh-huh.
You know, ladies are like a circle. It's infinite.
Okay.
If you draw a circle, do the two ends ever touch?
Do they ever touch?
Yes.
A true circle. I'm going to say yes, but you're going to tell me no because they're infinite.
Pi is infinite.
Pi is
So
infinite.
if you start off and you keep drawing the circle, they will never touch.
Huh.
Because
See,
pi
I
is
learned
infinite. The no numbers ever match up. And that's
Never
why
thought
when you-
about that.
If you walk east, you continuously walk east. If you walk west, you continually walk west.
Except if you're on the North Pole.
No. You gotta realize north and south is different. But if you take a street and today you walk halfway across, and the next day you go 1/4 of the way across, it's an infinite number, it never matches.
Never matches. See, I learned something too.
It just
Keep half.
gets bigger and bigger numbers. For infinite,
Yeah.
it never ends, forever and ever.
Yeah, okay. That sounds good to me. I'm getting a lock power up here.
Keep on walking, Richard.
Ah, I'll have to use that.
Come to an end.
See, you learn something new every day.
I learned
And
that
so-
from a physics professor and I shot him. I said it does come to an end.
Oh, excellent. All right, number 10. If a well pumps oh, they've already worked it out. Yeah. A well pump pumps 650 gallons per minute using 1.5 pounds of chlorine per hour. What is a milligram per liter dosage per day? So you have to make sure, look at all those units. Do they comply with the units that is necessary? We're going to keep our little circle up here and write in what they give us. All right, what's given?
650 gallons per minute
Oh, so that means I got to do what?
multiplied by 60 and by 24.
Okay. And then do what?
Times 8.34.
All right. So once I multiply by 60 times 24, don't forget to divide to convert it to MGD. So I'm waiting on that number first.
936,000 gallons.
Needed an MGD.
0.926.
I heard an MGD on this side, but I didn't get a confirmation on that side. So you're just doing this. What does that mean, Neil?
0.936.
Excellent.
But you also got to establish how many pounds of chlorine you used in a day. So you got to
What's given?
So you got to give that 1.5 times 24.
So I have 1.5 pounds per hour. He multiplied it by 24. Why?
4 hours into a day. You need your dosage per day.
Super. There are 24 hours in a day. Okay, that will give me the pounds per day. So 1.5 times 24, 36 pounds per day. Now can I work it? Yes? All right, cool. And I am looking for milligrams per liter. Let's see if we learned our life lesson. All right, the consensus of table number 1, what answer did you all come up with? 4.61, wow. That's what you all got to? Okay. What about table number 4? Get out the way, Bessie, so we can work it. I can understand that too. And if you have something to add any time, jump in there. If you have something to add or another approach at any point, jump in there.
Oh, yeah, it's going great. As long as you're having fun with math. You know, most people don't have fun with math.
No.
So again, going back to just establishing what 1 milligram per liter is. And then you
Okay.
just have to divide that by the total.
Excellent.
Well, take the total, divide it by the one, whatever
Right. Always break it down to that one unit. Would y'all come with table 2?
4.6.
We're all on the same page. 4.61 milligrams per liter. Excellent. All right. Number 11 is the bonus. And when you get the bonus right, that means you get a prize, right? So, I'm going to let you all work the bonus. You get it right, we get a 5-minute break before we complete the remainder of the math. So that's your bonus, a 5-minute break. Remember, 100% pounds divided by percent purity.
Are we talking a 24-hour day, or are we talking out that they ran out at 6 a.m. and the delivery came at 10 p.m.?
Let's keep it simple. Keep it simple. Keep it short and simple.
It's not enough.
Not enough?
No, if you need 64, you need 65 pounds. Actually, hold on.
Ah.
400 pounds, that's enough. Yes, it's enough.
Water system uses 50 pounds of chlorine per day, runs out the day before delivery. That operator is in trouble. Calcium hypochlorite is on hand, 65%. They have 100 pounds of that. Will it last until delivery?
So he's got 65 pounds per 100 pounds. So I've got 100 pounds.
Norm's like he's got it figured out. Are we in trouble, Norm? Robert?
Well, no, I just asked the answer 2 ways.
Mm-hmm.
See the second way.
What was the first way?
Well, if we take 65% of a 100-pound bag, effective, we
Right.
have 65 pounds effective, which is greater
Than
than
the
50
50.
pounds required. So yes,
We're good.
we'll make it.
All right, cool. So the second way, did you all hear that? He's absolutely right. We're good. The second way, how many pounds of the 100% do we have? How many pounds of the 100%? 50. So if we take the 50 and divide it by the percent purity that's on hand, which is 65, if I divided 50 divided by 0.65, how much will I need?
76.92.
And I have how much on hand? 100. So either way you look at it, man, I get to retain my job for one more day. You've earned a 5-minute break. 5 minutes, yes sir, and we'll be back. Remember what we said detention time was. Detention time is the amount of time something is retained in a basin or the amount of time it takes for it to move through the basin. So detention time in a nutshell, I know they give you a whole lot of formulas there, but I'm going to give you a very basic formula. And from that formula, we're going to convert back based on what we know about time. For instance, how many minutes are in an hour? How many hours are in a day? How many minutes are in a day? Super. You know how to do that conversion. So the very base formula would be capacity in gallons over flow rate. And from that, and we want that flow rate in gallons too. From that, we can convert to whatever detention time they require, right? All right, number 1. They want to know how many minutes will it take to fill a 4,000 gallon tank at 400 gallons per minute. What is the capacity of the tank? 4,000 gallons. What's your flow rate? 400 gallons per minute. What happens to gallons?
They cancel out.
Cancels out, leaving me with minutes. So 4,000 divided by 400 will give me how many minutes? 10 minutes. Number 2, how many hours will it take to empty a 20,000 gallon tank, 60 gallons per minute? Now you make the decision. Do we convert up front or do we convert at the end of the problem? In other words, do I change minutes to hours because they want the answer in hours? Do I do it first or do I do it last? It's on you. Do it what? Which way, Neil?
It's easy, is that way to convert right to hours.
Convert it, go ahead. All right. So you told me that there were how many minutes in an hour?
60.
So we have 60 gallons per minute times 60 minutes in an hour will give me how many gallons per hour?
3,600 gallons per hour.
Super. So what's my capacity?
20,000 gallons.
So I have 20,000 gallons divided by 3600 gallons per hour. Gallons will cancel out, leaving me with hours.
5.5.
Everybody get that? Okay, excellent. Number 3. How many days will it take to fill 300,000 gallon tank at 100 gallons per minute? How many minutes were in a day? 1440. So we have 100 times 1440, which will give me what? 144,000. So what's my capacity of the tank? So we have 300,000 divided by 144,000 gallons per day leaves how many days?
2.08 days.
Confirmation? Excellent. So detention time is easy, huh? Greg's like, you're not going to get me to say that. All right, all together. Number 4, sedimentation tank 75 feet long, 35 feet wide, 15 feet deep. What is the detention time in hours at a flow rate of 2 million gallons per day? Same concept, capacity in gallons. Do they give me the capacity in gallons? But I can get to it based on what we've learned earlier. What shape do we have? So, capacity in gallons of a rectangular shape was length times depth times, don't leave me hanging, 7.48 because I need it in gallons. Super. So what's the length? Plug it in. What's the width?
35.
The depth?
15.
And the flow rate.
2 million gallons per day.
2 million gallons per day because I want it in gallons. We're going to have to do some doctoring on that because they want it in hours. How many hours in a day?
24.
Okay. $75 times 35 times 15 times 7.48 give me capacity in gallons divided by 2 million times 24 converts it to hours. Got one answer? Dave is like, yes, he's on the right track. You like that answer, Dave? Excellent. Okay. Now, I could have converted this. How would I have converted that? What did I needed to do to that 2 million? Greg?
2 million divided by 24.
Super. That will be the alternative. Instead of multiplying it by 24 at the end, remember you make the determination whether you want to convert in the beginning or at the end. So had I gone that route where I wanted to have it in the right units to start with, take the 2 million divided by 24, which gave you like 83,300 and something, that you would have plugged in. Excellent. Questions? None. They're working ahead. They're like, keep it rolling. Number 5, a ground storage tank 20 feet in diameter, 10 feet deep. At 11 a.m., the operator begins filling at 500 gallons per minute. Will the operator be late for lunch at noon? And Neil's like, no, he's an operator, will never be late for lunch. May not get the... You don't get a lunch hour? No lunch? Not even 30 minutes?
You gotta eat on the job.
You're in the Northeast. You don't eat here. You don't stop.
You just work 8 hours straight.
You gotta just eat.
Eat on the go.
Yeah, basically.
Oh, wow. Y'all need to come down south. What do? Point me in the right direction. On number 5. We got to do the pi r squareds. I thought pies were round, but so once I do the pi, we're going to plug it in. I have a diameter of 20 feet. Okay. So my radius, 20 divided by 2, 10. Plug it in. Radius 10. Pi is excellent. And the depth or the height? 10 feet times 7.48. And my flow rate? 500 gallons per minute. Remember, this gives me gallons, which cancels out, which will give me how many minutes it will take to fill this storage tank. Okay, I heard an answer over there. 47? All right. Robert says it's 46.7. 97? Excellent. Operator starts at 11. Will he be done by noon? Yeah. Well, what's the difference?
They'll find a way to mess it up.
I resemble that. Does that work for you? Yeah.
Well, I did it 500 times 60, and I got 30, so I knew that. Like if that was a
You
true
went
or
the other
false-
way.
If that was a yes or no answer, I
Right.
would have answered yes, because I would answer.
Yeah.
Yeah, 500 times.
That's why I said 47 minutes.
Right. Another way of, we needed 23,000.
30, so I knew they would do it. Right?
Excellent.
I didn't know the time was good.
Yeah. All right, Paige, we're doing well, and we'll just pick out a few of the conversion factors due to the time. We won't do too